Hi everyone, Mr. Neighbor here, and today we're going to talk about significant figures. Before we talk about what significant figures are, I want to talk about two vocab words, which are accuracy and precision. So accuracy, that's how close a measured value is to an accepted value, where precision is how close a series of measurements are to one another, or how many decimal places are known. When you're talking about accuracy, think about a bullseye. It's how close you are to the center of it. Okay. When thinking about precision, think about how close repeated attempts are to another. When we talk about scientific notation, we're talking about how precise our values are. And we don't want to lie. We want to be as precise as the least precise value given. So, for example, if we're talking about the width of the earth, and then we're talking about a person standing on the earth, the width of the earth is probably going to be measured in miles. The person is probably going to be measured in feet. So when we combine the earth and the person, our answer is going to be a measurement of miles most likely, or kilometers if we're talking about the SI units. So if we have a measurement in kilometers, that's not as precise as the measurement of the person. But the thing is, we're not going to measure the earth to the nearest foot or meter like we would a person. We're going to measure it in big terms. So we have to go with the least precise measurement, which is the kilometers or the miles, the bigger thing for the earth. So even though we're measuring the width of the earth and this person on it, we're not actually going to focus on the meters or feet. We're going to go with the least precise measurement, which is the bigger unit, the kilometers. So think about place values in the same way. Your place value of 7.2 is less precise than the number you might be adding to it, which is 1.000007. We're just going to call this answer to be 8.2 because this isn't very significant when compared with this number. So that's what we're going to be talking about with significant figures. So we often call them sig figs. So why do you use sig figs? They're used to ensure values do not give false information by saying a measurement is too precise. Pretend a bunch of people held hands and the distance from the first to the last measured to be 41,000 meters. Then one more person, which is 0.6 meters wide, joined. Would you trust that the length is exactly 41,000.6 meters long? You shouldn't, because the first measurement may not have been measured as precise as that last person. It could be a little more or it could be a little less, but you don't know. So we use the least precise measurement. Some general rules about sig figs. Every non-zero number is significant. So 1, 2, 3, those are all significant numbers. 0 is only sometimes significant. So it's significant if it holds a place value. If it holds a place value, it's not significant. So these 3 zeros are holding the place value of 10, 100, ones, 10, and hundreds. So they are not significant. For example, 1, 0, 2, that is part of the number. It's not holding a place value. It's actually part of the number. So that is significant. And we never apply sig figs until we have our answer. That's when we're talking about adding, subtracting, multiplying, dividing. However, we're not doing that right here. We're just counting sig figs. And all of these examples have 3. So this has 3 sig figs. This has 3. 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 And this has 3. The key about this one right here is that the decimal says, hey, I measured to this point right here. I didn't measure to the hundredths. I measured to this point. So include this 0. I found that it was exactly 100. Here it's saying, hey, it wasn't 1.19. It wasn't 1.21. I found that it was exactly 1.20. So they include the 0 there because they measure to that precision. Here, though, There's no decimal point, so that makes that these 3 zeros not significant. If there was a decimal point, then it would, and then it would have 6. Same thing here. These are only place values. They are only placeholders, so that makes them not significant. You could write this number in scientific notation, and you wouldn't need these zeros. This number, you would have to write that 0 to be a part of the scientific notation, which you don't know how to do yet from this class, but that's what it would be. You can't just get rid of that 0. For this problem, where am I looking at? Right here, it would be 1.23 times 10 to the fifth. Notice I got rid of those 3 zeros because they were only placeholders, so I didn't need them. So that's some of the intricacies of sig figs. All of these have only 3 significant figures. So rules for addition and subtraction are different than rules for multiplication and division. So when you're dealing with addition and subtraction, you cannot be more precise than the least precise place value. Okay, so let's look at how many sig figs each number has. This has 3, this has 2, but that doesn't even matter. What's the least precise place value? The least precise place value is right here. The 1's place value. The 10th's place value is more precise. So when we add these two numbers, we would get out 124.6, but we have to round to the 1's place value. So that means that this 4 will be bumped up by the 6 to be 125. Let's look at the number of sig figs for each of these. This one has 3. Oops, you can't see when I write in white, huh? 3. This one only has 1. Again, those don't matter with adding and subtracting, though. You go to the least precise place value. So this place value right here would be the least precise, and that's the thousandths. For this one, its least precise is the 10 thousandths. So that's what we have to round to. We will add these numbers together, which would be 163. And then I have to round to this place value, the 10,000 place value. So that means that 3 is just going to drop off. Let's try this one down here. Number of sig figs, there's 1, 2, 3, 4. They're telling me that I did go to that 0 to measure. And then 3 here, but that doesn't matter. You only go to the least precise place value. So this least precise place value is the 100th spot. Here it is also the 100th spot. So our answer is going to be to the 100th. So we would add them and we would take the answer that we get out. So that is the answer right there. When you do this as is and when you include the significant figures. All right, now let's look at multiplication and division. So with multiplication and division, it's a different rule. You take the least precise number of significant digits of the given numbers. So write out how many sig figs each number has. This one's 2, this one's 1. This has the least amount of significant figures. So our answer will be that. So really this number is 35.7. But we only can have one significant figure. So that would just be this value right here. So it's going to round up to be 40. Let's try another one. Here we have 3 significant figures in the first number, 4 in the second. We have to take the least precise number of significant digits. So that will be 3, this one. So when I divide that number, I actually will get out, oh boy, 0.02086800209, lots of stuff. But I only can take 3 significant figures, so it'd be these 3. That 8 will round the 6 up. For this last one, we both have 2 significant figures, so the answer is going to have 2. Written in scientific notation, it would be that. Without scientific notation, it would be that big number in blue.